learn about conformation of alkane and cycloalkane. The learning objectives. 1. Student can understand the Newman structure of the alkane. 2. Student can understand the conformation of the cyclopentane and cyclohexane. 3. Student can find out the most stable conformation of the cyclopentane and cyclohexane. But before that, we have to know about isomers. Isomers is compound that have identical composition but different structure. Isomer divided into three, namely constitutional isomers such as geometrical isomers, functional isomers, and positional isomers. Next is stereoisomers such as enantiomers and diastereomers. And the last is conformational isomer like the following picture, which shows the conformational of butane, which consists of gauze, eclipse, stagger, and anti-conformation. In this video, we only discuss conformation, especially the conformation in alkanes and cycloalkanes. Now, we discuss the alkane conformation first. As we know, alkanes have a simple carbon-carbon single bond. In higher alkanes, there is no such bond in methane, but ethane onwards all alkanes have a carbon-carbon single bond. So, this always rotation of this single bond to form a different spatial arrangement of carbon atoms, forming different conformation of such alkane. As we know, in organic chemistry, it was found that you can twist the single bond of a molecule to change the arrangement of the atoms without changing the chemical formula of the compound. So the different arrangement of atoms due to the rotation of such bond is known as conformation, and its molecule known as conformer. To understand conformation, we will study the Newman projection. So, Newman projection is the better ways to visualize the different conformation of a molecule. Now, we learn about how to draw Newman projection. The molecular structure of ethane is 2,2,6,8, and we can describe the ethane structure in several structures, such as the condensed structure, calculate, and horse projection. In this video, I use ChemDraw application, so we start from horse projection to draw Newman projection. First, we make a Newman projection for ethane at 0 degrees, meaning that there has been no rotation. Next, we make the Newman ethane projection when rotate 60 degrees by rotating one of the branches 60 degrees. Then we frame it in a circle to make the Newman projection, like in video. Next picture, we make a Newman ethane projection when rotate 120 degrees by rotating one of the branches by 120 degrees. Then we make into the cycle to make a Newman projection. It is the same way before. Last, to make ethane with the Newman projection rotation 180 degrees, it is the same ways as before. So this is the Newman projection of ethane. As we can see in the picture, the ethane structure at 0 degrees is equal to 120 degrees, and this is called the eclipse conformation. And the conformation of ethane at 60 degrees is equal to 180 degrees, and this is called the staggered conformation. Now we try to draw Newman projection of butane. As we know, the molecular formula of butane is C410H. With the same way, we draw Newman projection of butane from horse projection. Start from 0 degrees. So, based on the previous example, we can conclude that the Newman projection only produces two conformations, namely eclipse and staggered. But in butane, which has different branches, the eclipse and staggered conformation are still divided. Namely, when it has a rotate or angle between methyl is 0, it is called totally eclipsed. When it rotates 60 degrees or angle between methyl is 60 degrees, it is called gas. When it rotates 120 degrees, it is called eclipse, and when it rotates 180 degrees, it is called anti-conformation. So what is more stable between eclipse and staggered conformation? The answer is staggered conformation. This is because eclipse conformation, in which the substituent on adjacent atoms are in the close distance to each other. This is caused the eclipse conformation to become unstable because the adjacent species generate very large electron repulsion. And the staggered conformation is a molecular conformation in which the groups or substituents of adjacent atoms are most evenly placed on each other. This makes this conformation the most stable, because similar species that are far away will produce less repulsion energy. And the last is Gauss-on conformation, midway between the eclipse and staggered conformation. And the last discussion is about conformation of cycloalkane, but in this video we just discuss two types of cycloalkanes, namely cyclopentane and cyclohexane. 1. Cyclopentane. Based on Bayer theory, cyclopentane is represented by a flat or planar conformation with all carbon angle of 108 degrees. But the flat conformation results in a slight strain, and the 10H atoms are in an eclipse position, so that to reduce this strain, a cyclically folded conformation is formed, which is called the envelope conformation. In the envelope conformation, 4 carbon atoms are in the same place and 1 carbon atom is isolated. The lone carbon atom is called the endocarbon. And the bond angle at the envelope conformation is reduced to 105 degrees. The interaction between hydrogen atoms is also reduced, so the energy is smaller so that it is more stable. Next, cyclohexane. There are several conformations of cyclohexane, namely a. Flat conformation. Flat cyclohexane is very strained. Not only is their angle strained, but every carbon bond is eclipsed, so there is also tremendous torsional strain. Next is half chair. This results in significantly less torsional strain and angle strain. Next, both conformation. In the both conformation, these hydrogen are held together in such close proximity that their electron could come close enough together to reveal an effect known as van der Waals strain. In twist both conformation, there is still significant torsional strain since there are two carbon bonds about which the hydrogen are not perfectly staggered. The last is chair conformation. The chair conformation is the most important conformation of cyclohexane to understand. This is the most stable conformation of cyclohexane. The chair is a perfectly unstable molecule. There are no eclipsing interaction. The conformation along its carbon is staggered. Okay, that's all my explanation about conformation of alkane and cycloalkane. I'm sorry for any mistake. See you and thank you.